Hello, welcome to another lesson in geometry. Today we are covering section 2.5, reasoning in algebra and geometry. So we're going to go back and look at some of our algebraic reasoning that we've done in the past. Okay. All right, so quick review. Circle each equation. So the only thing we should circle here is the second one. This is an expression. Doesn't work. This is also an expression, and this is an inequality. So an equation is two expressions separated by an equal sign. And remember, an expression or an algebraic expression has numbers and variables and operators. So notice no equals in the second, or the first and the third one, or inequalities. Okay. Write an equation to represent each problem. Sarah has 5 more than twice the number of apples that Greg has. If Sarah has 21 apples, how many apples does Greg have? So we could do something like this. We could let x equal number of apples Greg has. Okay. And then we can write that over here. Sarah has 5 more than twice the number of apples that Greg has. So Sarah has 5 more, so that's adding 5 onto the end, of twice of Greg's. So 2 times x is twice of Greg's, and then she has 5 extra. But we also know another thing that equals the number of apples Sarah has. Sarah has exactly 21 apples. So over here is an expression for how many apples Sarah has in terms of Greg's. And over here is a number that stands for exactly how many apples Sarah has. I could solve this equation to find out how many apples Greg had. Okay. All right, your brother does 1 less than twice the number of chores that you do. If he does 7 chores, then how many chores do you do? So here we'll let x equal number of chores you do. And we're going to use that x to help us write your brother's chores twice, and then we could solve it to find your chores. So your brother does 1 less than twice the number of chores that you do. So he does twice of your chores and 1 less than that. Remember, less than changes the order just like more than of the add or subtract problem. All right, if he does 7 chores, so he does 7, how many chores do you do? So here's how many chores he does, and here's how many chores he does in terms of your chores. So you could solve this to figure out how many you do. Okay. All right, vocabulary builder. Our vocabulary word today is justify. Justify. Okay. Related words, justice, that's the noun for it. Justification is also another noun, or justifiable is an adjective, or justly is an adverb. So definition. To justify a step in a solution means to provide a mathematical reason why the step is correct. So we're using deductive reasoning. We have to have some math reason that we know. Okay. When you justify an action, you explain why it is reasonable. So when you justify an action, you explain why it's reasonable. Okay. All right, so draw a line from each equation in column A to the property you would use to justify it in column B. So I might say 3 plus 7 equals 7 plus 3. So what reason, what math property do we know that would help us say that? Okay, and this one is the commutative property of addition. Remember, a commutative property says we can add in any order we feel like. Okay, all right. 12 times 4 equals 4 times 12. So this is the commutative property of multiplication. We can multiply in any order we feel like. And then 2 times 5 times x equals 2 times 5 times x. We didn't change the order we multiplied, but we have parentheses to help us tell which ones to do first. Okay, so when the parentheses move around, but we don't change any of the numbers, this is the associative property. And in this case, this is the associative property of multiplication. Okay. And then lastly, same thing, we want to add in a different order. So instead of adding 1 and 9 first, we could add 9 and 53 first. So this is the associative property of addition. Okay, on the second page, we have the key concept here, properties of equality. And we learned these all in Algebra 1. This is how we solve equations. We do things to both sides. So let's take a look at it. If A equals B, then B can be replaced by A in any equation. That's the substitution property. We learned that in algebra when we did substitution principle. Okay, substitution method of solving systems of equations. We can also multiply both sides of an equation by a number. So if 2 sides of the equation are equal, we could times both sides by the same number, and it would still be equal. We also learned that we could divide both sides by the same number as long as that number was not 0, and the equation would still be equal. We'll go over here. We learned that we could subtract the same thing from both sides, and the equation would still be equal. And for adding, we learned that we could add the same thing to both sides, and the equation would still be equal. And then we have 3 new properties of equality you probably didn't talk a lot about in Algebra 1. The reflexive quality just says, hey, a number is always equal to itself. We didn't have much use for that in Algebra 1. The symmetric property says, well, if a number is equal to another number, then that number should also be equal to that first one. So we can flip around the equal sign. And we would do that sometimes. Some people had equations like this, and they really like this stuff to be on the left side. So we said, oh, it's okay. You can change the sides and work it out. Okay, we did that one a good bit. And lastly, we have the transitive property, which we didn't use much in Algebra 1. It looks a lot like the law of syllogism, but it's an equality property. It says if A is B and B is C, then we can cut out the middleman and just say A is C. Okay. All right, then we also use this next key concept down here, the distributive property in algebra a lot. We said if we had a number being multiplied to the sum of 2 other numbers, then we could just distribute that in and make it the sum of the products instead. And it worked fine with subtraction here, so the difference of the products. Okay. So here's an example. If we have 5 times 24, then a good way to think about this in your head is to say, I might not know 5 times 24 really easy, but I know what 5 times 20 and 5 times 4 is really easy. So you could break this 20 into the sum of 20 plus 4, and then you could do 5 times 20 and 5 times 4 and multiply them separately, the products separately. So this would be 100 plus 20 equals 120. Okay, it's a good way to think about numbers. Okay. All right, same thing could happen here. Instead of writing 17, we could change that to 20 minus 3, and then use the distributive property to multiply the extra 3 in. So 20 times 3 minus 3 times 3, which will give us 60 minus 9 for 51. Okay, so if you didn't know what 3 times 17 was, you could break it down and make it easier because you probably know what 3 times 20 and 3 times 3 is. Okay. All right, justify your steps when solving an equation. So once again, we have a problem kind of broken over 2 pages. I don't like that they keep doing this, but let's give it a try. So what is the value of x? Justify each step. So given AB bisects RAN, circle the statement you can write from that given information. So if AB cuts the angle RAN in half, then I know that RAB, this part over here, should equal that part over there. So RAB should equal BAN. Let's see if we can find that. There's RAB and there's BAN. So that's the one we should circle. Okay. All right, flip it over. Let's finish this problem. Use the justifications below to find the value of x. So RAB is equal to angle BAN. That's what we just got. Okay. And measure of angle RAB is also equal to the measure of angle BAN. That's congruent angles have equal measures. So we can go from the congruence in step 1 here, the equals with the squiggly on top, drop the squiggly and add m for the measure. Then we have numbers. Okay. And then we can substitute x equals, let's go back and look what we got here. We need this page again. All right, x equals, and I need to erase a little, 2x minus 75, because this thing is the measure of RAB, and this is the measure of BAN. So when we get on this side, x equals 2x minus 75. Then we can use the subtraction property of equality. Okay, so to get 0 equals x minus 75. So they moved all the x's to the same side. And then we can use the addition property of equality. That means add something to both sides that's the same. In this case, we'll add 75 to both sides. And now we found the value of x. Okay, so notice over here, though, we have a new set of stuff. We have all of these reasons behind our deductive reasoning. We have the given, what we started with. We have the definition of angle bisector. That gave us this statement that we got on the other page. Then we have congruent angles have equals measures. That gave us that statement. Then we did the substitution property here. We substituted x for RAB and 2x minus 75 for BAN. And then we have the subtraction property of equality and addition property of equality. And our new thing is we used to do this in chapter 1, but we didn't do this part with it. So we're learning how to put our reasoning behind it. So notice we have revisit this key concept again, properties of congruence. We solved these 3 properties on the other page, but they knew we didn't spend a lot of time with them in Algebra 1. Okay, so we have reflexive property, symmetric property, and transitive property. I'm going to break this into a little table here. So this is reflexive property, and here's 2 examples. AB, segment AB is congruent to segment AB. So this is properties of congruence. We did equality on the other page, but they're the same for congruence. We just changed equals to congruent, okay? And then we have angle A is congruent to angle A. So we can say things about our geometry shapes that they are congruent, and we can do it over a reflexive property. So we can say they're congruent to themselves, okay? Symmetric property of congruence works just like the symmetric property of equals, okay? You could say like, hey, if this segment is congruent to this other segment, then that other segment's also congruent to this one. We can flip them around, okay? And it seems kind of silly that we would do that, but we'll see some reason in proofs later, okay? All right, and then we could do the same thing with angles. If angle A is congruent to angle B, then angle B should also be congruent to angle A. And then lastly, we have transitive property of congruence, okay? If segment AB is same as segment CD, and segment CD is congruent to segment EF, then we can cut out the middleman here and say that AB is congruent to EF. And you can do the same thing with angles. If angle A and angle B are congruent, and angle B and angle C are congruent, then we can cut out the middleman and say A is congruent to C. Okay, so we can deduce these things. All right, complete each statement. So if P is congruent to R, and R is congruent to A, then that means P is also congruent to A. And this is using our transitive property, okay? If X is congruent to N, and N is congruent to Y, then X is congruent to Y. This is also our transitive statement, okay? So we can cut out the middlemen of these N's to say X is the same as Y, just like up above we cut out the middlemen of these R's, okay? And then our last one, if L is congruent to T and T is congruent to Q, then L and Q must be the same. And this is one more example of our transitive property, okay? Cut out the middleman T and we can see that L and Q are the same. All right, so our first proof, 2-column proof here. Okay. Write a 2-column proof. Given that AB is congruent to CD, we want to prove AC is equal to BD. Okay. So the given is what information we know. If we look at our picture, we can see these red marks here and here. Okay. So that means AB segment is the same as CD. And what we're asked to prove should be the last line. That's what we're trying to get to. So they wrote the whole proof out, the statements. We have to come up with the reasons behind those statements. So that's going to be your job a lot in geometry. And I don't want you to write things like, oh, it's postulate 2.1. No, we're going to write the reasons that they give us. Like, what does postulate 2.1 say? Okay. All right. So the first thing we are given a given. We have to be given some information to start with. Okay. So that's the given information. And then we needed to make, let's see, that given turns into AB equals CD. So we started with congruent segments, and then we said the segments were equal. That means we're talking about the measures of them. So that means we know that congruent segments have equal measures. We learned that in chapter 1. Okay, so we can write that down. That's how we go from step 1 to step 2. All right, step 3, they just say BC equals BC. Well, they didn't get that from steps 1 and 2. They got that from our picture. BC equals BC. And this we could just say, hey, this is segment BC. It's still equal to segment BC. And this is the reflexive property of congruence. Okay, that's a squiggly on top of my equals. Except we don't have a squiggly there. So this is the reflexive property of equality. They kind of skipped over it. They should have said the segments were congruent and then the segments were equal, but we'll just go right to the equals. Okay. All right, so now given these two statements, they added BC to both sides. So they said something like this. Hey, we can add that to that statement above. So AB plus BC and CD plus CD. Okay, so they added these two together and these two together. Okay, well, we're adding the same thing from both sides, so this is the addition property of equality. Okay. And then what are we going to do? All right, so let's see. Somehow AB plus BC turned into AC, and BC plus CD turned into BD. So we'll go back at our picture here, and they took this red one and this red one and turned it into that big red one. Okay, and then also they took this little blue one, or this little green one, and this little green one, and turned it into that big green one. Well, we know that property. That's the segment addition postulate. So segment addition postulate. And what does the segment addition postulate say? So that's basically saying, remember, the two little ones add up to the big one. Okay. So notice I didn't call it postulate 2.1, but we can call it the segment addition postulate. Okay. All right. And then lastly, we got AC is congruent to BD. All right. So that means we had equal measures, therefore we have congruent segments, and that's the definition of congruence. And this is usually the point in class where kids go, oh my goodness, I had to know the names of all those still. And I say, yeah, remember I told you it's going to keep coming back. So if you've forgotten some of these, make sure you go back and study some of those names from chapter 1. Okay. All right, let's flip it over and see what's on the next page. So on our last page, we have a lesson check. So once again, this is where you pause the video and you see if you can do this stuff. Okay. All right, welcome back. So fill in the reasons for this algebraic proof. Okay. So we are given 5x plus 1 equals 21, and we're trying to prove that. So we know that the given's going to be our first statement, and right now, sometimes it won't be actually. And the proof is going to be our last statement. So we're trying to prove that thing. All right, so we have 5x plus 1 equals 21, 5x equals 20, and then x equals 4. So we were given the proof part, the statements. We just need to come up with the reasons ourselves. Okay, so these questions will walk us through that. So the first step in the proof is, what are you given? Okay, so that's why this is there. Okay. And then underline the correct words to complete each sentence, and then circle the property of equality that justifies the step. Okay. For the first, number 1 was added or subtracted to both sides of the equation. Well, what did we do? It looks like we subtracted 1 to both sides. It was minus 1 and minus 1. So this is the subtraction property of equality because we subtracted from both sides. And then each side of the equation was we divide it by 5 to make that 5 go away. So this is the division property of equality. So what should be over here for reasons 1, 2, 3? Well, reason 1 should be the given. We were given that equation, 5x plus 1 equals 21, and asked to solve it, okay, or prove that x equals 4. And then our second step, what do we use for our reason, was subtraction property of equality. And our last step, we were asked, we had to use the division property of equality to make it work out. Okay. All right. At the end, math success. So one more time, go back through and make sure that you know all these properties. The hard ones were circled for you again. So these were the ones they said to go take a big peek at, because these are the ones you probably don't know or remember. And reflexive property, symmetric property, and transitive property for both equality and congruence. And then what is a proof? And then we did a bunch of 2-column proofs, okay? And then you can rate yourself. And if your rating's low, remember, go back and watch again. All right? See you in class next time.